what we're going to do now is look at more on finding combined areas. And now we're going to be taking our shapes and doing a little bit different things with them. So as we look at this, what I'm really going to be looking for right now is I want to find all of this unshaded area. All those corner areas. Like, how much area is that when we're looking at this? So let me start by saying, okay, well, we have a square, and let's say this square is 6 meters by 6 meters. All right, it's a square, so it's 90 degrees at all the corners. And I need to find that green area. Didn't want to do that. I wanted to take and move all of it. It's not moving. All right, well, let's pretend. I'll just have to leave it there for right now. All right, I want to find that green area, and what I look at is I see, okay, well, this circle that I have here, there's the center, the distance from the center to an edge, well, the distance all the way across the circle would be the same as this distance all the way across the circle is going to be the same distance as it is all the way across the side. So this total area back and forth across this circle is 6 meters. So the distance only from the center to the edge is going to be 3 meters. And that's very, very important to remember. Well, let's try to remember. I have two things here. I've got an area of a square and area of a circle. Area of a square is equal to a squared, or the side times the side. So then I write the formula and then I say, okay, that's equal to, plug in the numbers. So the side length is 6. So I'm going to have 6 meters, and that's going to be squared. Squared, recall again, is a number times itself. So we have 6 times 6, so we have 36 meters squared. So that's the area of everything inside of the square. But what I want to do is I want to find only the green area, which means I do not want the circle. If I can find the area of the circle and remove it, or subtract it away, I'll be then left with only that green shaded area. So I need to think of, well, what's the area formula for a circle? And that's equal to pi times r squared. And this is why I said finding this 3 is important up here, because the 3 is the radius. That 3 is my radius. So I go back down here to my formula, right down there, and I insert the numbers. Always write down the formula first. And I'm like, all right, then I start adding numbers. Pi we'll use as 3.14159 or so. And then that's going to be times the radius, 3. All right, that was from up here, that 3. This 3 up here comes all the way down and goes there, and it's 3 squared because it's the r squared, radius squared. So I have pi times radius squared. And then I use my calculator. Remember to always use order of operations. This is why we spend so much time on it. That r squared is what I do first as PEMDAS, my exponents. So I go 3 squared is 3 times 3, so that's 9. 9 times 3.14159 is 28.27. 28.27. So to find this green area, these little corner spots, I need to take the whole area and subtract away the area I don't want. So I will take this 36, which is the whole area, meters squared, and I will subtract away what I don't want, which is the 28.27. So I write down 36 minus 28.27, and that gives me 7.73 meters squared. Rounded, of course, in this case, to the nearest hundredth, 10th hundredth. All right, I have 7.73 square meters, or meters squared. That's the area then of the little green area. That little green area of the corners. All right, next idea. if we look at something like this, we're going to find the area, and then it's always be careful. Pay attention to what the problem's talking about. Are you finding the area of, in this case, is it the green shaded area or the red shaded area? So what I want you to find is I want you to find the area of the red shaded area. That is all of this area here. All right. There's no numbers on this yet because I want you to always be thinking, well, what is the shape? What is the shape? All right, so I've got this shape here, which a lot of you are going to be able to recognize and say, ah, yes, that's a rectangle. And then I have the big shape. All right, I need to make some markings on here. So I do this, and then I do this on the sides. And I don't know if you could really see that because I use the same color. 2 arrows here, mean these sides are parallel. Arrow here means, those sides are parallel. So I have both a rectangle and I have a parallelogram. So I write down the formula. That's base times height. Oh, look at this. This is also base times height. But they're different bases. And then as I look at this picture, actually I'm going to notice the height from the bottom. So if I extend that line out there, let's extend that line out. If I measure up to the top, so this is not part of the parallelogram. This is just I kind of drew out an extension line of the bottom piece there. Drew out an extension of the bottom. And I measure from the base to the top. Both the rectangle and the parallelogram have the same height. So let's give that a height, an actual number now. Let's say that this is 4. That's 4. All right. The length of this top part of the parallelogram is 6, and this is 1. All right, so then you got to start filling in different parts and pieces and keeping track of what's what. All right, so as you're doing this, here's what I want you to do on your little quarter slip of paper. I want you to first write down what is the base and height of the rectangle, what is the base and height of the parallelogram, and then if you can, finish the problem. That is, find the area of the rectangle, find the area of the parallelogram, and I'll say parallelogram minus area of rectangle. Show me that work on your little quarter sheet of paper. Get that done and bring it to class. If you get stumped, at a minimum, I need to see this with these two numbers inserted. What do you think the base of the rectangle is? What do you think the height of the rectangle is? What do you think the base of the parallelogram is? What do you think the height of the parallelogram is? Fill that in, bring it to class, and we'll see you when you get there. Bye-bye.